today's math video!
The year, we only have a couple of videos left, and for this last set of videos we're going to be looking at trigonometry, and this will be a pre-cal preview for you. You can get a little bit of a taste of what you'll be seeing next year in pre-calculus. So you have this worksheet. I gave it to you if you were in class last week, but I would like for you to get that worksheet out and we can work along, and I have a few notes that I would like for you to make on the page, and make sure you keep track of this packet. If you were not in class, you can always go to the online calendar and I'll have the worksheet there and you can print that out, or you can just wait until I see you again and then I'll give you a copy then. Okay, so at the top of this worksheet you can see some of the vocabulary that we're going to be using: trig, function, sine, cosine, tangent. So you've probably heard of some of those. We're going to have cosecant, secant, and cotangent, standard position, initial side, terminal side, angle of rotation, and so on. So you can see whenever we get to those words what each of those mean. Then we have a definition. A trigonometric function is a function whose rule is given by a trigonometric ratio. A trigonometric ratio compares the lengths of two sides of a right triangle. So we're going to be looking at a lot of triangles, or trigonometry. All right. The Greek letter theta, which looks like this zero with a line through it, is often used to represent the acute angles of the right triangle. The values of trig ratios depend on theta. Alright, so here's 13.1. This unit will be set up or split up into three different sections. So for 13.1, well, let's look at these notes in this video. Okay, so right angle trigonometry. Okay, so trigonometric functions and reciprocal functions. So we're going to use our good old friend the Pythagorean theorem to find the missing side of a right triangle. A squared plus b squared plus c squared equals c squared. Remember, c is always going to be the hypotenuse, which is going to be across from the right angle. So let's just look at what we have on the left side here. We'll have that sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. And you can remember these, and you've probably already heard this before. SOHCAHTOA. So if you're just reading it left to right, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We also have these three functions, which are cosecant, secant, and cotangent. Cosecant is just the reciprocal of sine, so we have hypotenuse over the opposite. Secant of theta will be the hypotenuse over the adjacent, and cotangent is the adjacent over the opposite. It doesn't quite sound as cool, but if you wanted to, you could remember it's cow. I don't know if that's even helpful. Or just know that each of these letters will be the reciprocal of the SOHCAHTOA. Alright, so we have this 3, 4, 5 triangle. And we've got all 6 of our trig functions on the right-hand side. So sine of theta. So theta is right there. So sine is opposite over hypotenuse. So that would be 3 divided by our hypotenuse, which is 5. Hypotenuse is always opposite from our right angle. So if sine of theta is 3/5, the cosecant is supposed to be the reciprocal. This is a mistake right here. That should be 5/3. That wouldn't make sense if it was the same thing as sine. Okay. Cosine. So cosine is adjacent over the hypotenuse. We'll have 4/5, which means secant will be 5/4. And then tangent will be opposite. So here opposite of theta is 3 over adjacent, which is 4. So we have 3 divided by 4. So then cotangent would be 4/3. So sorry about those mistakes, but make sure you have those written down for your corrections. Okay, let's look at some special right triangles. We have 30, 60, 45. Will be the ratios that we're going to be using for these two triangles with those three numbers. Okay, so remember we've got 30, 60, 90, special right triangles, and 45, 45, 90. And the ratio for these, so if you're trying to figure out, if you know one of the sides, you can figure out the other because it's based off of ratio. So for a 30, 60, 90, opposite of the 30 will be 1. Opposite of the 60 is the square root of 3. And opposite of the 90 is 2. So if we had letters here, we could say if this side was x, then this side would be x square roots of 3, and this side would be 2x. So that's another way of looking at it. So if we are looking at the sine, so sine is opposite over hypotenuse. That would be, so let's erase this so we're not confusing ourselves here. Okay. X over, so sine would be x over 2x. Well, that's just 1/2. So the sine of 30 degrees is 1/2. The sine of 60 degrees, so we have x square root of 3 over, so sine opposite over hypotenuse is 2x. So the x's would cancel, leaving you with this square root of 3 over 2. We have cosine of 30. So that would be, cosine is adjacent over the hypotenuse. So we have the square root of 3 over 2. Cosine of 60, its adjacent would be x. So adjacent has to do with the angle of, opposite and adjacent, all of these have to depend on which angle you're looking at. So next to the 60, adjacent to the 60 would be x over the hypotenuse of 2x. That reduces to 1/2, and so on. Whenever you get to tangent, so if we're looking at the tangent of 30, that's going to be opposite over adjacent. Well, that's 1 over the cube root, or square root of 3. But remember, we have to rationalize that denominator, so we multiply on the top and the bottom by the square root of 3. So we'd have the square root of 3 over 3, which is how they got that number right there. So this is actually what you would write down if it was asking the tangent of 30 degrees. And then the tangent of 60, so that would be x over x squared with, no, opposite. So x square root of 3 over adjacent of x, that cancels out to just be the square root of 3. So that's how it'd work for a 30, 60, 90. For a 45, 45, 90, it's always easier to remember because two of the sides are going to be the same here. That'll be a 1:1 to square root of 2 ratio. So for the sine of 45, it doesn't matter which angle you use. So sine is opposite over hypotenuse, so that'd be 1 over the square root of 2. But then you have to rationalize that by multiplying by the square root of 2 on the top and the bottom. And then that's how we get square root of 2 over 2. Tangent of 45, opposite over adjacent. So we have 1 over 1, which just equals 1. And cosine of 45 would be adjacent over hypotenuse. Rationalize that denominator, and you get the square root of 2 over 2. And then finally, you'll notice at the bottom of the page is this darling picture, and it says the angle of elevation and depression are alternate interior angles, therefore have the same measure. So whenever you have problems that are asking about angles of depression and angles of elevation, so say you have a plane going by and we've got a watchtower. So if this plane is flying horizontally and its path is parallel to the line of sight of the person sitting in the tower here, the angle, the line connecting those, you'll have, if you're looking from the top down, so from the plane down to the tower, that would create an angle of depression, so that'd be going down. From the tower going up, looking up to the plane, that would be an angle of elevation. But since the line of sight here, those dashed lines are parallel, that means this line, this diagonal we've created here, will have alternate interior angles, which means it will have the same measure. So you'll have a couple of those in your homework problems as well. Okay, so that is 13.1 and the first section of our trig unit notes. You'll be using this for the next couple of days, and I will see you in class and in the next video. Hope you're having a great one. Bye.